Let's wait a little bit, but we're going to do some of the topic of today in the meanwhile. So today we're going to talk about mainly the bridges. It's going to be a little bit, maybe a little bit different as the previous webinar because well, we're going to talk about, of course, about the sensors, about the technology. You know, we at every webinar there are different people, and we there are someone is I can see, I can tell, and I'm gladly there is a recurrent, but we got always new people, so it's good to do a recap. But in the last part of the webinar, we would see how, let's say, how to work and with the senses, how to extrapolate informations. Okay, so it will be about also the application, the case study that we have. I think it's really important to show how you work with the senses, what kind of parameter you extrapolate from the analysis, what you could do more. So that's why I prepared the webinar to have also a last part where we can discuss. I can show you some example, but in the meanwhile you can ask me questions about how we do this, what we do, and and a couple of things more. Yeah, I see that there are still people joining now, so we'll wait a couple of minutes more to get all the people inside the room, and yeah, we'll start. And meanwhile, I will tell you that there is a nice article about the Colosseum that we've placed some sensors on it. If you want to go to our page and read it, it will be amazing. We did a good job with the customers of us, which is called IMG in English, and we did the Colosseum monitoring. So it's an interesting thing. Okay. All right. I say that we start. Okay. So welcome everyone. I'm Ferdinando. I am the founder of Move Solution. I am the managing director. So what I do, I manage all the company in the port, and I am a tech guy. I like technology, and it's been a nice I guess now 4 years journey with Move, and it's been an incredible journey that the company it's done in the last 4 years, and especially in I'd say this year and a half, 2 years, that it's growing a lot and really fast. So as I said before, today we're going to talk about bridges. I have a nice, let's say, relationship with bridges because it's one of my favorite civil structure. We have started the company from the bridge problem. Let's say I call it like that. The bridge problem. It's not that the bridge have only one problem. They have different kind of problems. But let's say we started trying to make the bridges safer, safer than before. Okay. So let's start. Let's talk about a little bit more about the problem, about the problem that this kind of structure have. So here we speak not only about the bridges, but I'd say also about dams, railways, subway, tunnel underground. There's for my experience, I mean, for my opinion, there is only one goal that an infrastructure company, like, just make an example, Network, Autostrade per l'Italia, Amtrak, this kind of company needs to have. It's safety. Safety is the, I'd say, the most important target that those companies should have. So they should be able to know when a structure is not, let's say, safe, but not even, let's say, we don't want to arrive at the point that it's not safe, right? So when it's not safe, it means that it's really dangerous for life. It's really dangerous for people. So the infrastructure owner needs to know when structural changes happen on the structure. And it's really important, because if they are not to understand when something is changing, that is get really tricky. It's really tricky, because at that point we don't understand when something is changing and might cause a unsafe problem, or something is changing and I don't know how it will react in the future. So the safety is the most important things, and we see that environmental changes, this climate change that we're living right now is just creating a explosive mix of problems, because structures are aging. In Italy, we have 50 to 70 years old bridges, for example. So this is really old, and they're made in concrete, and concrete has problems. So you put on top also the climate change as well, and you find with a lot of the problems that are happening right now. So you can understand that one of the main tasks that is asked to the owner of this infrastructure is to be sure that are safe. Okay, so the safety, of course, is a hard problem. I mean, not saying it's easy. I'm saying it's really hard, especially if we think about it. Okay, let's say we have a infrastructure company, a fake one, right? Let's say Move is a infrastructure company. Okay, the goal is to handle 300 bridges, a kilometer of roads. When there are so many structures in my portfolio, in our portfolio as a infrastructure company, it's hard to know where to focus first, where I should focus. What is the bridge that needs help right away? On which bridge, for example, I need to invest? Or another question is, which one of my bridges are changing status? So are getting into a, let's say, in another, let's say, part of the life of the bridge where the conditions are not the one that the designer think that the bridge has. So those are really hard problems. So let's get back and see the question that I said, right? So which is the structure that needs investment? So this is I'd say the first question that the infrastructure company have to ask. What is the bridges that needs right now help? Second is, how can I understand if my structure changed by behavior? So how can I know if something is changing? So one interesting thing, and I would like to report another fact, right? So if we take the aerospace market or the automotive market, okay, cars, this kind of system, a car, for example, has a chassis, as a part of the a structural part of the cars, right? How they know that they design it correctly? So they use techniques that are called dynamic vibration techniques that basically by know the vibration, how vibration act, or on over the chassis, over the structure, I can understand mechanically how it's going to perform, how well it's designed, if it's correct that working that in this way. So this is if we speak about the structural market, the structural problem on bridges or other structure, the problem is not that, it's not that different if you think about it. So we could use vibrations that brings informations on how the structure is made, for example, or how long is a span, right? Because, for example, frequency depends on length. So if you get a beam and you got a beam, let's say longer, you will have a lower frequency probably. Okay, that depends on mass, on stiffness, on other parameters. But the idea is this, right? It's like a guitar, right? If you get a guitar, he has different strings, and the strings have different, have the same length, but there are different forces, right? Because and they are, let's say, one is thicker, one is not, and going over it. So this parameter on how much forces can be related on, for example, the frequency, so how they vibrate. And on bridges, basically similar, okay? So vibrational monitoring, that is what is called, is a really interesting technique, because from vibrational monitoring, I can get informations about the structural situation of the bridge, for example. That is really interesting. Right now, there is one of the parameter in this vibration analysis that is called modal analysis, because we take in account a parameter called the modal shape. Modal shape, modal frequency, we'll talk about later what it is. But to have an idea, the modal shape is how vibration run through my structure. So if I have a structure with problem, I would see that, as in this case, and then I'll talk about it in a second, but you can see from the picture that the vibration, the modal shape along this bridge is completely asymmetrical. It's not symmetrical. So I'm repeating this for my English if it wasn't quite clear. The modal shape in this picture, you can see that it's not symmetrical. So if I take the middle and I watch one part and the other part are not, not the same. They're not having the same shape. So this, for example, is not a good sign. So the modal shape is really interesting, because with that, we can understand if, for example, the vibration run in all the bridge in the same way. If this modal shape changes over time, it means that something is changing in the structure, and then need to be aware, because it's a really bad sign. For example, this is a famous failure bridge, which is the Morand. You know that in Italy we had a huge problem with Genova, with the Morandi bridge. It failed about 2 years ago now. In August, I think August 8th will be the third year, because it was in 2018. This picture is taken from a document that was published from a university, which they made a study, I think a year before I failed, or 6 months before. But they addressed that by making a modal analysis, by making vibrational analysis, they understood that there was something bad, because they could see that the parameters weren't, let's say, symmetrical. They, for example, they were different from the FEM, the finite element model that they designed it. So they had a lot of different things which didn't really match out. So it was a really, red light sign, for example. And so now, okay, to do model shape and model analysis, what is called at the end dynamic monitoring, is really hard. That's why usually dynamic monitoring was done not continuously. It was done, for example, two times per year. So and it was done like this. They were bringing, for example, accelerometer. They were cabling the accelerometer, and once they were cabled all together, they sampled, for example, per a morning, so 6 hours, and then they just left. They make the measurement, they take the analysis, and they got a report. Now you can understand it. Then make it like that is really complicated, because you cannot see continuously the changing in this. So they were doing, for example, one every 1 year, maybe 6 months top, 2 years, because it's complicated. I need to go in the structure, cable, put all the cable, put accelerometer in the cable, synchronize accelerometer. It's really complicated. So one of the facts that probably dynamic monitoring weren't really spread out. It was the lack, let's say, of technology that were enabling to make this quicker with less expensive, right? But in a certain way, if I could have a dynamic monitoring system, so if I could measure every day the changing this parameter, I could do I can have an early warning system. So before it actually goes in a state which is really dangerous, I could use these informations. Okay, I could see this switch before that something is really changing, right? So before that, my structure going in this status that it might be unsafe, it might not be correctly. Okay, so basically, as we said, dynamic monitoring is really interesting. You can see here in the picture that it's in a lot of information. I can catch something before maybe it happened, but it's really hard to make it. Okay, it's really hard to make it. Yes, to let's say to implement it in the structure. So in a certain way, I think that we think that dynamic monitoring is changing right now. The idea of monitoring is changing how you monitor something, because you can in a certain way predict the failure before it actually happens. So this is really powerful. It's a really powerful technique. Now, also regarding dynamic monitoring is that you can do also other things. By making a dynamic monitoring, you can extrapolate these geometrical parameters, so you can check, as we said, these parameters if they change. So it's something that you wouldn't see by eye, you wouldn't see by making a slow, let's say, measuring, right? So it's something that you're not actually seeing if you're not performing dynamically the monitoring. Second, you can tune the finite element model, and it's really interesting that because you can tune it, you can design the bridge, you can see how the bridge is on your model, and then you can catch the data from the field and see if this match, for example, can tune the model, or if you're sure that your model is good, is perfect, then you can you know that there is something wrong in your bridge that you're checking. And so you can track behavior analysis, you can check changing stiffness. So it's a lot on preventing before that it failed. So this is what is about dynamic monitoring. Now, dynamic monitoring is complex. Why it's complex? I need to sample a high frequency. I need algorithms to extrapolate this information, because It's not only about an FFT, it's about complex algorithms. So you can understand it at dynamic monitoring stuff. So what is that we're doing right now? We're giving the system that is a dynamic monitoring system. So we designed the dynamic monitoring system to be wireless, to not having any problem. But as we know that monitoring is about also on creating, your project, your application. So you need also static monitoring as well. So we said we need to make a family of sensors that are also static. So that's what we've done. And we said we want to design the algorithms to be automatical, to be really accurate, and to extrapolate information. And all of that is made, again, completely wireless. So this is what we do. We make dynamic monitoring, static monitoring really easy. Okay, we make the monitoring really easy. That's what Move Solutions does. Okay, talking about the system, we have the sensors that are on field. They capture the data, and you can install it in 2 minutes because they are completely wireless. They communicate the data over a gateway. The gateway can be placed on a, let's say, long range from the sensors. They communicate over LoRaWAN, which is a IoT protocol, probably one of the most used IoT protocol right now in the market. Then the gateway has a LTE 4G PoE, so an Ethernet connection, for example, power over the Ethernet PoE. That's what it means. They communicate the data to a processing cloud server. Now, let's stop 1 second right here. We will talk about later. We supply a cloud system, or we could supply also a on-premise system, or we could do a private, let's say, just for you server that is yours but is handled from us. Because we got a lot of time this question, right? Can I place it on my server? Is it only cloud? Can I not? I'm not really sure. So we give you all the choices. We give you the cloud, or we give you the processing on premise on your server, or we can, let's say, buy the server for you and handle everything, okay, for you. But it will be still private, okay? It will be as yours, but handled from us, okay, as a support. So this is the flow. So from the sensors that are on field, the LoRaWAN system enable me to communicate data over the air with this protocol in a smart way. Then we have the gateway. The gateway communicate to the server, and then got everything on cloud or on premise, depending on how you want it. Now, why is LoRaWAN nice? Why it's good? LoRaWAN is good because it enables you to communicate over 15 kilometers, for example. So you got a really long range, but at the same time, you have a long battery life. The battery life can stay up for 8 years. We say that we give you 2 years for dynamic product, to 8 years for static sensors, okay? And this is enabled to have a fast installation. You can install the product in 2 minutes, really. And we say with no maintenance cost. That is true, but I would say more really low maintenance cost. They always say maintenance cost because you might need to change the battery in the future. After the battery life is done, you need to change it. You can change it by yourself, but there will be a cost of changing the battery. So that will be the maintenance cost of the sensor. Okay, so you can understand it's a lot of impacting in a good way the economy of your operation, having a wireless system. Now let's go a little bit faster on the product. And then we can go on the application, and we could go on some question and answer. Okay. So one of the main interesting products that we got requested all over the world is the deck. The deck is one, I think the first, let's say, IoT sensors that is made to sample displacement, dynamic displacement. It's designed mainly for bridges or for other railways application, but mainly for bridges. And what deck does. So the deck sampled continuously, it never stopped. And what the deck does, it's once sample the point of where it's installed, instead of sampling the velocity or acceleration, it sample the displacement. This displacement needs to be dynamic, so needs to be, let's say, fast. Needs to be like certain vibration. Okay, it has a certain bandwidth, which is perfect for bridges. Maybe it won't be perfect for other kind of application, but for bridges it's perfect. And it can sample at 100 hertz continuously for 2 years with a huge accuracy. We are talking about 0.01 millimeter. So really small movement. Okay, and it is really good, because when we're talking about dynamic monitoring, we'll have movement that can be also on millimeters, centimeter, but then we will have we will have movement that are really small. So it's important to have this kind of resolution and accuracy as well. We made a lot of comparison with the radar in the same bandwidth, and we published a couple of scientific papers that show how they're good, how they match pretty much exactly. Probably with different, of course, with a different cost. The deck is really cheap compared to that radar, and that's what is really interesting. What you can do with the deck is that you can do two kind of analysis. You can analyze displacement over time, dynamic displacement over time, so you can see the changes in the dynamic displacement, or you could perform dynamic data, dynamic frequency analysis based on the data that you have received. And this is really powerful because you can extrapolate the frequency, you can track the frequency, you can track a lot of the things. So that's really interesting as well. And then we have the Move accelerometer, which is another dynamic sensor. Now, the Move accelerometer have different functionality that are really interesting here, okay? One of the most requested functionality for perform in the best way structural health monitoring. So the OMA analysis, the modal analysis, is to have the sampling between the accelerometers between themselves correctly synchronized. What it means synchronized? It means that they need to perform a sampling in the same time. Let's say they could have a little shift in pace, but they need to be really high synchronized. Now, one of the issue when we're speaking about synchronization is that synchronization is really, let's say, power consumption, high power consumption. You can synchronize it with a GPS, GNSS, but it will consume your battery. It will consume it really fast. So we have designed a system inside the accelerometer, which it enable us to, let's say, phase the accelerometer between itself and make different sampling during the day that are completely synchronized at 100 microseconds top with different phases. So you can understand that it's really good to make structural health monitoring. It's made especially for not only for bridges, but it's made also for building analysis, seismic analysis, tunnels analysis, vibration analysis. It can be done for a lot of things, not only for bridges. And so the another good thing about the accelerometer, it has different size of sampling. So let's say you want to perform more vibration analysis. So vibration analysis usually needs to have a lumped parameter, so like peak-to-peak value, RMS. So we could we put a functionality that change the frequency of the sampling, so we can go up to 500 hertz of sampling. So really high, okay, for sampling. So this is open also the construction side and vibrational monitoring, where we need other kind of parameter, PVV, PPA, other kind of parameter. Now let's go on the static product. Static product are really important, anyway, essential for the monitoring. We have tiltmeter, which are the most common used product for measuring rotations. Now, the Move tiltmeter is really accurate, really accurate. It's about plus minus 0.001 degree in accuracy on a small rotation. So really good accuracy on rotation. It's perfect for rail, for tunnel and bridges, because on the cloud platform that we'll see in a bit, we place the different tools where you can catch different kind of let's say different kind of analysis. You can catch different data from different fields, and you can perform static analysis. So you could perform, for example, a load test with the tilts, and you could perform a measured deflection with the tilts. So you can understand that we combined deflection, we combined we combine the tools to perform analysis, not only for the bridges, but also for rail. For example, cant twist, deflection of the railways, many different things. Okay, it is automatical on our cloud. And then we have the analog and digital nodes. So what is about analog and digital nodes? So analog node is a logger, let's say. So you can place geotechnical sensor plugged to the analog node. So once the sensors is plugged, okay, we can read the sensors automatically with different interfaces. We have 420 milliampere, PTC, NTC, millivolt, overvolt, pod, Modbus 485, different kind of interfaces. Of course, the analog node has the analog interfaces, which every channel have all the interfaces, all the analog interfaces. So it means that, for example, in channel 1, you will find a 420 milliampere, PTC, millivolt, POT, and the same for channel 2, 3, and 4. Now, you could program the Move logger, the Move analog node, to have different interfaces for channel. So let's say you want to have plugged in the channel 1 the 420 milliampere, the 420 milliampere crack meter, and then on the second and third, you want to have a millivolt sensors. You could do that. They are completely independent, and that's a really good thing. Another thing is the Modbus. We have the digital nodes, which is it's a logger that is digital. It can read the Modbus for digital probes. Okay, so we could read, for example, in placing clinometer chains, all the sensors that run on Modbus, for example. And we talk with different manufacturers of geotechnical sensors. So we could have we could work with them to have the protocol support on our logger as well. Now, we have the gateway, which is a LoRaWAN gateway, is IP67. It could be, you could use it on the Ethernet, or you could use on the SIM card. So the LoRaWAN gateway is really nice, it's really compact, and it's made for outdoor. It's rugged. It has a nice case for damage that could be outside. You could place it also in a pool, which is the preferable position, so you can catch a long range. You could use the LoRaWAN gateway also for other application, not also structural head monitoring. You could use for IoT, smart city, different kind of application. Okay, but it's a really nice gateway. Now the monitoring platform. So we pay a lot of attention on the platform. Why? Because the platform is where the data are stored. The platform is where a customer experiences the monitoring. So we are paying a lot of attention in creating the new tools, new things. During this year, it will be out a massive update in the next days, but in this year we will increase the functionality of the platform in a huge way. Okay, so in the platform there is everything you need. You can find that graph, you can find the events that the sensors has transmitted. You could find the tools that we're going to speak in a little bit. Alarms, for example. Everything that you need, you can find it directly on the platform. So you don't need to buy another software. You could use directly our cloud platform. Then in a little bit, I'm going to talk how to connect other platform to our, but the idea is you could use the platform for everything you need. And I'll tell you a little bit more about how we charge for a platform. So the platform is created to be charged when you use it. So let's say 1 month you don't need to monitor anything. So you get the sensor back from the site and you want to place it in the warehouse. Well, no problem. You can just dismiss the platform and you will pay it when you activate it back the sensors for the monitoring. So this is open. A good thing is that you need to pay for something that you don't use. Okay, that's what I'm really concerned also in this. So the one that customer pays something for not need. So you can pay when you want. I mean, not when you want, but when you use it. Okay. So on the platform, there are statistical tools that help you to analyze dynamic monitoring or static monitoring. Most of them, the statistical tools are used for dynamic monitoring. So we got, for example, FFT, which is not really a statistical tool. I wouldn't call it statistical. It's more deterministical. So it's not statistical, but it's we call it a statistical tool because it's in the, let's say, in the part of the suite where you analyze everything. Then we have the FDD, which is a modal analysis algorithms to extrapolate frequency, damping, model shape. Then we have density probability function algorithms as well, anomaly amplitude detection algorithms. So there are different kind of algorithms, okay? I'm going to show you right now what you could do. For example, one of the most used algorithm that we have in the platform is the OMA tool. The OMA, it's help you to track, the HOMA tools help you to track daily the frequency, the modal frequency of the structure, so of a bridge or a building, and you can track and see variation daily, for example. Or there are other tools still in the modal analysis that are able to show you the cluster, the PSD of this model shape that you're visualizing. So many different things, many different tools to help you the analysis as you want. Another one is the analysis of distribution. What is the density, the probability density distribution of the phenomena? It's really interesting because you can statistically analyze if something is changing over time, okay, by using this kind of tool. Since we are talking about the bridges, one tool is the bridge deflection algorithms to perform load test. So we created a nice algorithm. I will tell you more about in the application that I'm going to show you now. But it makes you capture the let's say the deflection that a bridge have during the load test, for example. Okay, so this is really interesting because when you perform a load test, if you perform it with a tilt, for example, you need to extrapolate the deflection, which if you do it, for example, with a first order equation, it's easy, but it's not accurate. It's not accurate at all. So you want to have something more advanced. So we have designed a tool for you to make that. Okay. There is another tool which is the railways void detection. It's a can twist tools. It's not about, of course, about the bridges, but it's something that you might need for the railways market to perform the analysis needed. Okay, and of course the classical graph, beautiful graph, CSV, and other things. So now let's get into applications. Okay, I know that there've been a couple of questions, but I'd rather to go 1 second in the application, then we'll have the time to speak also about questions and other things. So before going into application, the bridges for dynamic, let's say, monitoring, let's see how I can use the platform for static monitoring as well. So there's this bridge in Sicily. It is called Ponte Petrusa. It's a new bridge in Sicily, and they were asking, our customer were asking for a load test system. So we gave 6 tilts. Let me show you how they placed it on the span. So we gave them 6. You can see on there are 3 spans, and they did the test on the span 3 and span 2nd, and the 4th span you got 6 tilt for 4 span. Okay, they're placed on different position. Basically, they're placed close to the edge of the bridges of the span, and the other are a different length. But with 6, you got a nice accuracy about the deflection. So the bridge static deflection tools gives you automatically the response of this deflection captured from the tilts basically in real time. What real time means when you receive the data from the tilts, right away it plot the deflection, so it's completely automatical. So let's say you place that the tilts need to sample every 2 minutes or certain time around like that. You can have an update of this deflection of this load test every 2 minutes automatically with our system, for example. And now the algorithm, as I said before, is not linear. So it's a non-linear equation. It is a fitting of function that best fit the deflection. Okay, giving some conditions. It's a little bit more, let's say, we go into too much technical things, so I will leave it apart. But the algorithm is really good. It's really good. You can see this is our deflections measured with the system. You can see they're beautiful, really beautiful. Of course, it was a load test with a load focus in the middle, so that's give you this kind of U shape, really nice. This was load test on span 1, span 2. It's really nice, interesting, and it's really accurate, really accurate tools, okay, for load testing. Now let's get a little bit. Let's change a little bit the application with the dynamic monitoring. I had another a nice customer of us, which they need to perform modal shape on a structure that I'll show you in a bit. So we provided the accelerometers, and the accelerometer have this functionality, which is synchronized, and it can perform synchronization sampling. So this, as you can see, it was placed in this pole, which it could be placed on to other poles, but basically they were placed at different length. Okay, the green dot are accelerometers, so just 3 accelerometers, not much, not more than that. Let me show you the result. It's really interesting. So with just 3 accelerometer, they were able to track frequency and the model shapes for the monitoring time. And it's really powerful if you think of that. You can see changes in this shape that it will mean that something's not right daily, really. You can do this every day for all the time that you want. You can see how much is easy, powerful, cost effective. Right? It's really interesting, this. Okay, so model shape with different kind of shaping. First mode, second mode, third mode. Okay, and that's done with accelerometer. It's crazy. It's I really love this kind of application. Now let's go more in the bridge, right? So the bridge is a complex structure. So what I showed, for example, just for 3, we might need it for just 1 span. We need more different things. But what I'm going to show you with this application, with this case study, I'm going to show you how you can combine everything, okay, to a total monitoring. So we got for it's a real case study, is a pre-stressed concrete bridge, and we placed 4 deck, 4 accelerometer, and 4 TMTs, and 3 analog nodes. So it's a complex bridge. Now, let me tell you this: it's not just a easy bridge, but you can see that the number of sensors is still real limited. It's not a lot. Actually, I said it is 1 bridge, but by the way, are 2 twin bridge, one placed besides the other. So there are 2 bridges. We placed the deck for dynamic displacement analysis due low traffic passing. The accelerometer to perform model shape analysis. Then we place the tilts for load testing, so load test or rotation that could have the concrete that couldn't be, let's say, good. Then on we place 3 analog nodes because it's a pre-stressed bridge, so they have cables along the bridge, and they put a load cell for every cable to measure the tension of this cable. Okay, they wanted to be sure that it doesn't lose, right? So one of the main things that they did with our tool is the frequency shift. They were able to see that in month, due temperature, due environmental parameter, and due the traffic that were changing in a certain way, masses were increasing. There were kind of problems there, okay? But there were problem, and we were able to understand that there were problem before it actually happened. That was really good thing, because what happened is that I'll be real quick with the story, but they see that the basically the cable the pre-stressed cable were starting to get loose. We understood it before using the frequency analysis, because we were seeing that these frequency were changing too much. So we got the early warning first, and then we see that we were able to correlate this with the load cells that were losing force. But the frequency analysis was earlier than a significant amount of losing in the load cells. So that's really why dynamic monitoring is really good. The early warning system is really, really interesting. This another early warning system. You can see that the frequency is really spread in a period of time. So this spreading is not something that you would like to see in a ear monitoring. You would see that it's really narrow. So the frequency means that, for example, let me rephrase that. So if you get a frequency at a certain hertz, okay, that let's say it's the first note, you wouldn't want to see that there's change. It can change due to environmental things, but then it shouldn't change much, right? So we shouldn't see as narrow, okay? But here in this case, when they monitor, they see that in just a couple of months it was changing too much, too fast. That there was another signal that something was wrong, okay? So you can see that using just DAC, using just 2 DAC per bridges for accelerometer, we could do this kind of analysis. That is really powerful. I got the early warning system in place, and with the load cells as well, with the analog node, I were able to cross-correlate it, let's say, the two phenomena. So that was really interesting as well. Okay, so we are really at the last part of our session. I've seen that there are questions, so I will get. Okay. We have a couple of message. So Tom Jensen, which is from Netherlands, says, congratulations for the final for UK, Italy. Let's say finger crossed. Let's see, how we will perform. But there was unrelated to the webinar. So anyway, thanks, Tom. The other question is, you could synchronize with LoRa. Yes, we synchronize using LoRa, but not using the LoRa synchronization, which is not, let's say, accurate. It's not accurate at all. Now, can we use the Think network or the Netherlands KPN LoRa one? Yes, we can. We will need to work with the network provider, but I know a lot of guys from TTN, from KPN LoRa, from TTN. We know a lot of the people, and they are doing massively job. So yeah, let me know what do you need for that. Other question is, does the DAC sensor have a built-in temperature sensor in it? Yes, it has. It has a temperature sensors in it, so we can correlate temperature with the events that is changing. What is the version of LoRa protocol you support in the sensors? We support different version, but right now we don't support yet the 1.1. It's a 1.0 something version that we support. The other question is, which network server you use for private LoRaWAN deployment? We could use different LoRaWAN provider. Right now we use LoRaIoT, which is they do an incredible job and an incredible product, so we use that. Okay, and we could place a private LoRaWAN network server with IoT or another one that you prefer. So another question is from another person is, what's the difference between DAC and accelerometer? So the DAC measure displacement, which is another, let's say, quality in what you're measuring, right? So displacement is really interesting because it's easier to understand it. If I would have acceleration and I would understand, the magnitude of what I'm measuring is not, in term on spatial movement is really tricky, right? So when we speak about bridges, it's more interesting about the displacement than the acceleration. So that's why DAC is really interesting for the bridges. I have another person that asks, what is the smallest defect in the RC bridge which can be detected by accelerometer frequency analysis? This is a good question. Basically, depend on what you're monitoring. So there is no unique answer to that. Depending on how you elaborate the data and what kind of data you have. But we could measure something in around 0.01 Hz, which is by literature is enough resolution and accuracy to see a variation in a really small variation in frequency caused by change in stiffness, crack, and other things. Of course, it's not a easy how to say it. It's not. It's a complex analysis, and we need to take out also the temperature and other things. But by making this analysis, you can catch smallest variation, really small with this kind of product, really small. Another question is, is the sensor installed? Can a simple engineer from a reseller system integrator do this? Yes, Tom. We could do that. Basically the sensors are installed with a plug that we give to the customer. It's a plate that it's installed in really 2 minutes, just 4 screws. So by being a system integrator, you can do this in no time really. Okay. So another question is, how do you separate the frequency changes due to temperature from those due to defects? Another good question. So there are analysis with a correlation effect that can give you this kind of analysis. So you can let's say clean your data from temperature by using PCA analysis, principal component analysis, a couple of things that are really interesting. So it's possible by using basically statistical analysis. You can split the two effects from temperature to from the defect to changes in the structure. And okay, so we are right on time, 4 p.m. and I think we are done with our time. So thank you for the attention. Thank you for the timing. It was a pleasure. The webinar is recorded, and we'll publish it so you could review it and see it back. Okay. So thanks again. Have a great weekend and a good day. Thank you. Bye-bye.